So get this. I asked for some articles about quantum computing, and suddenly I'm like down this rabbit hole
Oh, yeah.
of physics and tech that honestly it feels like Star Trek.
Right.
But here's the thing. It's not sci-fi.
Yo.
It's real computers that could change, well, pretty much everything.
Pretty much.
So buckle up, everyone, because we're going deep on quantum computing.
Okay.
What it is, how it works, why you should care, all that.
Yeah, what fascinates me is that we're not talking about just faster computers.
Right.
It's a totally different way of processing information,
Okay.
using those strange rules of quantum mechanics.
Okay, so now you got to break this down for me.
Yeah.
Because the minute I see quantum mechanics, my brain just starts to melt.
I get it.
Both these articles keep mentioning qubits, though.
Yeah.
What are those, and why are they so special?
So imagine like a regular computer bit,
Okay.
like a light switch that's either on or off,
Yeah.
1 or 0.
Right.
Now imagine a qubit is like a dimmer switch.
Right.
It can be on, off, or anywhere in between,
Whoa.
all at the same time.
At the same time.
That's called superposition.
Okay.
And it's one of the big keys to the power of quantum computing.
Hold on. So a qubit can be both 1 and D0 at the same time?
Yes.
My brain just did a backflip.
It's a lot.
How does that even work?
It works because we're tapping into the behavior of subatomic particles,
Uh-huh.
like electrons,
Okay.
which can actually exist in multiple states at once.
Okay.
It's kind of like that analogy of a spinning coin.
Oh, yeah.
Until it lands, it's both heads and tails.
Okay, I think I'm sort of following you.
Good.
But how does this translate into actual computing power?
Right.
Is it just because each qubit can just hold more information?
It's more than that.
Okay.
Each additional qubit increases the computational possibilities exponentially.
Exponentially.
Think of it like this.
Okay.
With regular bits, you're adding lanes to a highway.
Got it.
With qubits, you're suddenly able to teleport.
Teleporting data. Okay, now you're talking my language.
Uh-huh.
But the Investopedia article mentions something even weirder.
Oh, yeah.
Entanglement.
Right.
What's that about?
Entanglement is where things get really spooky.
Uh-huh. Okay.
It's when two linked qubits influence each other instantly, no matter how far apart they are.
No matter how far apart.
So imagine you flip a coin here,
yeah.
and at the exact same moment, a linked coin on the other side of the world flips the opposite way every time.
Whoa.
Yeah,
That's trippy.
it is.
So it's not just that each qubit is powerful on its own,
Right.
but they can be linked together to create this like interconnected web of computing power.
Exactly.
Wow.
And that's where things get really interesting in terms of what these quantum computers might be capable
I
of.
bet. But before we get too far ahead of ourselves,
Sure.
let's back up a bit.
All right.
These articles talk about manipulating subatomic particles
Right.
using things like charges or polarization.
Mm-hmm.
Can you give us like a simple way to picture what's happening inside a quantum computer?
Yeah, imagine like a tiny compass needle.
Okay.
The direction it points could represent a 0 or a 1.
Okay.
But in a quantum computer, we can manipulate that needle using things like magnetic fields or lasers
Okay.
to make it point in multiple directions at once,
Oh, wow.
representing that superposition we talked about.
So we're essentially like encoding information onto these tiny particles
Yeah.
and then controlling them in this way that allows for all these like mind-bending quantum states.
Precisely.
That's wild.
But here's the catch.
Okay.
To maintain these delicate quantum states,
Yeah.
we need some pretty extreme conditions.
Oh, really?
The Whatties article mentions super cool temperatures,
Okay.
like negative 459 degrees Fahrenheit.
Whoa, that's colder than space.
It is.
Bro, that's some serious refrigeration.
It's a lot.
No wonder these quantum computers are so complex and expensive to build.
It's a huge engineering challenge.
Yeah.
And because these qubits are so sensitive,
Yeah.
any little disturbance from the environment can cause errors.
Oh, no.
And that's a major hurdle
Right.
that researchers are trying to overcome.
So let's talk about the elephant in the room.
Right.
The challenges.
Mm-hmm.
Even if we can build these super cooled, ultra precise quantum computers,
Yeah.
how do we make sure they're actually reliable?
That's where error correction comes in
Okay.
with regular computers.
Yeah.
It's relatively simple to detect and fix errors,
Right.
but with qubits,
Mm-hmm.
which are constantly flitting between states,
Yeah.
it's a much tougher problem.
So even reading the output of a quantum computation could mess things up.
Yeah, it's a bit like trying to observe a delicate snowflake
Oh.
without melting it.
Oh, okay.
The act of measurement can actually disturb the fragile quantum state and introduce errors.
Wow.
So it's one of the big puzzles that scientists are grappling with.
This is starting to sound like a delicate dance.
Yeah.
Trying to keep these qubits happy and error-free,
Right.
while also trying to harness their power.
It is.
No wonder we're still in the early stages of this whole quantum computing thing.
Exactly.
Yeah.
But despite the challenges,
Yeah.
the potential rewards are so enormous that it's driving a global race
Oh, wow.
to unlock the secrets of quantum computing.
Speaking of that race,
Mhm.
both articles mention the usual suspects. Google, IBM, Microsoft.
Of course.
But are they all taking the same approach?
Actually, there were a few different paths being explored.
Oh, really?
Some are focusing on superconducting qubits,
Okay.
which need those super cold temperatures we talked about.
Right.
Others are working with trapped ions, which are individual atoms held in place by electromagnetic fields.
Wow. So it's not just about building a bigger, better quantum computer,
Right.
but also about figuring out the best way to even build one.
Exactly.
Okay.
And then there's the question of what we do with these machines once we've built them.
Right.
Developing the right algorithms and software is just as important as the hardware itself.
So it's a multifaceted challenge.
It is.
It requires expertise from physics, computer science, engineering,
All of it.
you name it.
Yeah.
It's pretty incredible to think about the brain power being poured into this.
It truly is. And while we may not see widespread quantum computers in our homes anytime soon,
Yeah.
the progress being made is astonishing,
It really makes you wonder what the future holds.
doesn't it?
But I think we need to take a break and let our brains cool down a bit.
I agree.
We've covered a lot of ground, from the basics of qubits to the challenges of error correction.
We've only scratched the surface.
I bet. Welcome back. So, last time we took a crash course,
Yeah.
Quantum Computing 101.
Right.
We talked qubits, entanglement, the whole 9 yards.
Yeah.
But I'm guessing you're not here just for like the theoretical physics lesson.
Right. Everyone wants to know, what can these quantum computers actually do?
Exactly.
The articles you shared, they're packed with potential applications.
Okay, so let's dive into the good stuff.
All right.
The Investopedia article talked about revolutionizing medicine,
Mm-hmm.
even mentioning genetically targeted medical care. Is
Oh.
that as sci-fi as it sounds?
It's closer than you might think.
Really?
Imagine being able to design drugs that are tailored to your specific DNA.
Oh.
Quantum computers could simulate how different molecules interact at an atomic level,
Okay.
helping researchers develop more effective drugs with fewer side effects.
So we're talking personalized medicine on a whole new level.
Exactly.
What about that example from Google?
Yeah,
Their quantum computer solved that problem in 200 seconds.
right.
That the Investopedia piece says would have taken a classical supercomputer 10,000 years.
It's a big difference.
What kind of problem was it even tackling?
It was a sampling problem,
Okay.
which might not sound exciting,
Yeah.
but it has huge implications for fields like materials science and cryptography.
Okay.
Think of it like trying to map out a vast unknown territory.
Got it.
A classical computer would have to explore every nook and cranny,
Right?
while a quantum computer could essentially teleport to different points,
Wow.
getting a much faster and more comprehensive overview.
Uh-huh. So it's not just like brute force calculation.
So,
No. It's a fundamentally different approach to problem solving.
exactly.
Speaking of material science,
Yeah.
one of their articles mentioned quantum computers could help us create entirely new materials.
That's right. Imagine materials that are lighter and stronger than anything we have today,
Oh, wow.
or superconductors that work at room temperature.
That would be incredible.
That could revolutionize everything from transportation to energy.
Yeah, it's like we're talking about unlocking a whole new level of technological advancement.
I think so.
But I have to ask about the elephant in the room,
Oh, yeah.
encryption.
Right.
If quantum computers are so good at solving complex problems,
Mhm.
does that mean they could break the codes that protect our online data?
It's a real concern.
Code.
The encryption we use today relies on mathematical problems that are very difficult for classical computers to solve.
Right.
But quantum algorithms, like Shor's algorithm,
Mm-hmm.
could potentially crack these codes much faster.
So is this the beginning of the end for online security as we know it?
Not necessarily.
Okay.
It's a race against time.
Okay.
While quantum computers pose a threat to existing encryption,
Yeah.
researchers are already working on developing new quantum-resistant algorithms.
That's reassuring.
Yeah.
Okay, moving on to something a bit less doom and gloom.
All right.
What about the potential for quantum computing in finance?
This is an area where quantum computing could have a major impact.
Really?
Imagine being able to optimize investment portfolios with incredible precision,
Okay.
or manage risk in complex financial systems more effectively.
So we're talking about not only making more money,
Potentially.
but also potentially avoiding major market crashes.
It's a possibility quantum computers could also be used for fraud detection, algorithmic trading,
Okay.
and even creating new financial instruments.
It's mind-boggling to think about how many different industries could be impacted by this technology.
It's a lot.
The What Is article mentioned quantum computing as a service, or CA.
Right.
What's that all about?
QAS is essentially cloud-based access to quantum computers.
Okay.
Think of it like renting time on a supercomputer.
Got it.
This could allow researchers and businesses to experiment with quantum computing without having to build their own expensive machines.
That makes sense. It sounds like it could democratize access to this technology.
I think so, at least to some extent.
But even with CARAS, wouldn't there still be a steep learning curve?
Oh yeah,
This stuff is not exactly plug and play.
you're right. There's a huge need for quantum programmers and experts who can develop the algorithms and software
Okay.
to harness the power of these machines.
So it's not just about the hardware, but also about building the whole ecosystem around it.
It is.
This is starting to sound like a major paradigm shift.
It is.
Not just a technological upgrade.
Right. And as with any major technological shift,
Yeah,
there will be challenges and unintended consequences.
of course.
We need to be thoughtful about how we develop and deploy this technology.
Which brings us back to the limitations we discussed earlier. Decoherence, error correction, the cost and complexity of building these machines.
Right.
It sounds like we still have a long way to go
I think we do.
before quantum computing becomes mainstream.
Yeah. But the progress being made is remarkable.
That's true.
And remember, the timeline is constantly evolving.
Yeah.
What seemed impossible a few years ago is now becoming reality.
I think what's most exciting is the sheer potential.
I agree.
It's like we're on the cusp of a new era of computing, and we're only just beginning to glimpse what might be possible.
It's a thrilling time to be following this field. Who knows what breakthroughs the next decade will bring.
Okay, I'm officially hooked. But before we get too carried away with all the possibilities,
Sure.
let's take a step back and consider the bigger picture.
Okay.
We've talked about the science,
Yeah.
the applications, the challenges, but what does it all mean?
Right.
What are the broader implications of this quantum revolution?
That's what we'll explore in the final part of our deep dive. We'll delve into the ethical considerations,
Right.
the potential societal impact,
Okay.
and the big question,
What's that?
what does a quantum future look like?
I can't wait. Join us next time as we wrap up our journey into the quantum realm. Welcome back to the final part of our deep dive into quantum computing.
It's been quite a journey, hasn't it?
It really has.
From those mind-bending basics of quantum mechanics
Yeah.
to the potential world-changing applications.
We've covered a lot of ground, but now I'm curious about the bigger picture.
Okay.
What does it all mean?
Right.
What are the implications of this quantum revolution we keep hearing about?
That's the question that's been on my mind too.
Yeah.
We're not just talking about a new gadget
Right.
or a faster computer.
Yeah.
Quantum computing has the potential to disrupt entire industries,
Whoa.
reshape global economies,
Wow.
and even challenge our understanding of reality itself.
Okay, now you're really getting philosophical on me.
Uh-huh.
But I get it. We've talked about all these amazing potential applications.
Right.
But what about the potential downsides?
Yeah,
Are there risks we need to be thinking about?
absolutely.
Okay.
One of the biggest concerns is the potential for job displacement.
Oh, yeah.
As quantum computers become more powerful, they could automate tasks that are currently performed by humans,
Right.
leading to significant job losses in certain sectors.
That's a valid point, and we've already talked about the potential threat to cybersecurity.
Of course.
If quantum computers can crack the encryption we rely on today,
Yeah.
what does that mean for our privacy and security online?
It's a serious issue that needs to be addressed,
Oh, okay.
but it's not just about cybersecurity.
Right.
There are ethical questions, too.
Like what?
Who will have access to this powerful technology?
Okay.
Will it be concentrated in the hands of a few wealthy corporations or governments?
Right.
Or will it be available to everyone?
Those are some heavy questions.
They are.
And I keep thinking about that whole idea of quantum computers being able to simulate complex systems.
Yeah.
What happens when we can simulate human biology with incredible accuracy?
Right.
Where do we draw the line between innovation and playing God?
It's a slippery slope, that's for sure.
Yeah.
And it's not just about the technology itself,
Okay.
but also about the intentions of those who control it.
Right.
Quantum computing could be used for good or for evil, just like any powerful tool.
So it's not just a technological revolution, but also a societal one?
It is.
We need to be having these conversations now before it's too late.
Exactly. We need to think about the ethical implications,
Okay.
the potential risks, and the long-term consequences.
Yeah.
We need to ensure that quantum computing is used responsibly and for the benefit of all humanity.
I'm sensing a theme here.
Oh, yeah.
It seems like with great computing power comes great responsibility.
Couldn't have said it better myself.
Mm-hmm.
And that's where you, our listeners, come in.
Okay.
We need informed citizens who are engaged in these discussions, who are asking tough questions, and who are demanding that this technology be used for good.
It's a call to action.
It is.
We can't just sit back and let the future happen to us.
Right.
We need to be active participants in shaping that future.
I completely agree, and I have no doubt that the coming years will be filled with both challenges and opportunities.
For sure.
The quantum revolution is just beginning,
Yeah.
and it's up to all of us to ensure that it leads to a brighter future for everyone.
Well said. It's been an incredible journey exploring the world of quantum computing with you.
It really has.
We've gone from feeling like our brains were melting
Uh-huh.
to being inspired by the possibilities
Mm-hmm.
and humbled by the responsibility that comes with such powerful technology.
It's been a pleasure diving into this with you.
And thank you, our listeners, for joining us on this deep dive.
Yes, thank you.
We hope you've learned something new, that you're feeling a little bit more informed and maybe even a little bit more empowered to engage with the big questions facing our world. And on that note, we'll sign off. Until next time, keep exploring.